Welcome to Circuits and Devices Lab. In today's video, we are going to learn how the experiment number 8, verifications of Thevenin's and Norton's theorem, can be performed using virtual lab. So, first we have to go to the virtual lab. For that, you have to go to Google and click virtual lab link in the search bar, and then go to the Electronics and Communication branch as we have done in the previous video. And in Electronics Communication branch, there are lots of laboratories developed by many institutions such as IITs. So usually we will select the basic electronics lab to do our experiment. But now we are going to do the verification of Thevenin's and Norton's theorem. So this experiment is simulated in the analog signals and network and measurement lab. So verification of Thevenin's and Norton's theorem are simulated in analog signal network and measurement lab. So you have to select this lab to perform this experiment. So once you click that lab, you will be shown the introduction of virtual laboratory in this page. So in that you have to select the list of experiments. So in list of experiments, we have to select the Thevenin's theorem. So we have to say first we are going to do the verification of Thevenin's theorem, and then we are going to do the verification of Norton's theorem. So first select the second experiment, verification of Thevenin's theorem. So select that. So once you select that, it will be shown the theory of Thevenin's theorem. So what does the Thevenin theorem states is, it is possible to simplify any linear circuit, no matter how complex, to an equivalent circuit with just a single voltage source and series resistance connected to a load. So this is our theorem, and we are going to prove this theorem. So this is your theory page, which covers the explanation about the Thevenin's theorem. So now we have to go to Procedure tab. So for that, select the Procedure tab. So this page covers the circuit diagram of Thevenin's theorem and also the step-by-step procedure to solve this theorem. So read it once, and then next we are going to start to do our experiment. So for that, select the simulator. So in simulator page, in order to perform the experiment, you have to click this link, which is click here to perform the experiment. So select that. So this is the page where we have to do our experiment, which is verification of Thevenin's theorem. So this is your circuit diagram of Thevenin's theorem, which consists of dp-dt switch. So dp-dt means double pole, double throw switch. So there are two switches, S1 and S2. So this is a source and this is a load. So the procedure is, keep all the resistances R1, R2, R3, RL close to their respective maximum values. Choose any arbitrary values of V1 and V2. So here, so this is our resistance R1 and this is R2 and this is R3. Now this is our voltage V1 and this is our voltage V2, and this is our ammeter reading. It shows our current value. Now first step, we have to keep the resistance value R1, R2 and R3 to any value as our wish. So here already they have fixed as 100 as R1, R2 300 ohm and R3 200 ohm. If you want, you can change this value by clicking this button. So similarly, you can also change the R2 and R3 value according to your wish. And we can also change the V1 and V2 value. If we want, we can change this to any value as we wish. So by clicking this box. Okay. And now we have to experiment the part select. So in the next step, we have to choose case 1. We have to do the case 1 experiment. So for that, we have to select this case 1 tab. So in case 1 tab, we just read this instructions and follow that to do the experiment. So first case 1, read select switch of S1 to power and S2 to load. So this is your S1 switch, DP/DT switch, double pole double throw switch. So in this switch, you have to click this drop down menu. There will be power, short, intermediate positions. So in that, as per the procedure, we have to select the power. Because in procedure they have given select switch S1 to power. And next step S2 to load. Then you have to choose the switch S2 and click this drop down menu and select to load as per our procedure. Next step, in case 1, simulate the program and observe the result from table 1. So after setting these two values of S1 and S2 or these two positions, you have to click the simulate button. So once you click the simulate button, you will be shown a load current in this box. The load current IL is 0.10645. So thus we have completed our case 1 procedure. Next, in case 2, there are two steps, A and B. So in order to perform the case 2A, Thevenin's voltage analysis, you have to click the case 2A tab. Now I have selected case 2A tab and then perform the first analysis, that is Thevenin's voltage analysis. So in that, your first step is apply switch S1 to power. So now I am switching S1 to power. And next S2 to intermediate. Now we have to select the switch S2 to intermediate. Next step, simulate the program and read the Thevenin's voltage from case 2 tab. So our next step is you have to select the simulate button. So once you select this button, you will be shown the Thevenin's voltage value as 82.500. So we have completed our case 2A, which is Thevenin's voltage analysis. Next, case 2B, Thevenin's resistance analysis. So for that, you have to select the case 2B tab. So once you click this button, you have to follow the procedure in case 2B. That is, apply switch S1 to short. So go to the circuit diagram, select switch S1 to short. Okay. Next, S2 to power. So then go to the S2 switch and then select the power. Next step, simulate the program and read Thevenin's resistance from case 2 tab. So our next step is click the simulate button and then you can note that Thevenin's resistance RTH is 275 ohm. So your Thevenin's resistance can be found by using the voltage value 220 and current value 0.8. By these two values you can find the Thevenin's resistance RTH. Okay. Next you have to perform the case 3. So using VTH and RTH determine load current. So while you are performing case 3 procedure, you select the case 3 button. Now case 3 is selected. So read the first line that specify the load resistance in case of the result table as the same load resistance entered in the main circuit. So we have to verify the load current value obtained in this case, which should be same as the load current which is in the case 1 tab. So for that we have to do the simulation of the program. So click the simulate button. So once you select the case 3 button, you can directly click the simulate button. So before selecting the simulate button, you can see the obtained VTH value in case 2 and RTH value in case 2 are entered here and RL value also entered here. Now we have to click the simulate button. So your simulate button shows the load current as IL is equal to 0.10645. So this IL value is same as the load current obtained in case 1 tab. So in case 1 tab, if you select the case 1 tab, you can see the same load current is obtained 0.106. In case 3 also you can obtain, you can see the same load current 0.106 is obtained. So next step, we have to fill the data to the table. So you have to fill all this obtained data to the table. So for that, you have to select fill the data to the table. So click fill data to the table button and then you'll be shown a box. Here the observation table is updated. Change the resistance and voltage sources values to take another observation. So click OK and then you can see the values are obtained in the observation table. So you can verify that load current from case 1 is 0.10645. Similarly, load current by the use of a Thevenin's theorem is 0.10645. So both these load currents are same and thus we have verified the Thevenin's theorem. You can also take the next observation, second observation by varying these values. So for that you have to vary the R1, R2, R3, then V1 and V2 values, and you can also change the RL value also. If you change all these values and do the same procedure, you can obtain the second set of readings in the observation table. So here. So after doing all this reading for the various values, you can print the values. So thanks for watching.